All, this is my fourth video in motion. So basically here I'll discuss a comparison between uniform motion and non-uniform motion. So uniform motion means when a body is moving with constant velocity, it is called that the body is undergoing uniform motion. Non-uniform motion means velocity is not constant. Either velocity is increasing or velocity is decreasing. It means the body is possessing an acceleration. When a body is moving with increasing velocity, we can say the body is undergoing uniformly accelerated motion. When the body is moving with decreasing velocity, we can say the body is undergoing a uniformly retarded motion or uniformly negatively accelerated motion or uniformly decelerated motion. So deceleration, retardation, negative acceleration, same thing. But in uniform motion, no acceleration word will come. So for uniform motion, we will generally use a simple formula, that is delta V, average velocity equal to change in position with respect to change in time, and instantaneous velocity equal to small change in position with respect to small change in time. Similarly, speed equal to distance by time. Only these three formula we are going to use. And another one thing, that is average speed equal to total distance by total time. But in case of non-uniform motion, what are the formula? The first important formula, average acceleration, already I have discussed in my previous video, equal to change in velocity by change in time. When change in velocity 0, average acceleration 0, so change in velocity 0 means velocity constant. So it is no more a non-uniform motion, it will become a uniform motion. So in case of uniform motion, acceleration is 0. So average acceleration equal to change in velocity with respect to change in time, and instantaneous acceleration equal to small change in velocity with respect to small change in time. But important three formula, V equal to U plus AT, V square equal to U square plus 2AS, and AS equal to UT plus half AT square. I think most of the 9th standard student has come across this formula, these three formula: final velocity, initial velocity, acceleration, time. Final velocity, initial velocity, acceleration, displacement. Displacement, initial velocity, time, acceleration. So basically there is a correlation between velocity, acceleration, time, velocity, acceleration, displacement, velocity and time. So these three formula will come into picture when we are considering non-uniform motion. So we'll discuss these things and we'll derive these things using calculus, that is integration. So within next two videos I'll teach you some important things of or some uses of derivative and integration. So for uniform motion, quickly I am explaining one thing. Suppose this is from A to B, B to C, C to D. Let's say A to B is 2 meter, B to C is 2 meter, C to D is 2 meter, and let's say the body is taking a time 1 second in going from A to B, another 1 second in going from B to C, another 1 second in going from C to D. So this is an example of uniform motion when a body covers equal displacement in equal intervals of time. Equal displacement in equal intervals of time. But in this example, I am, let's say, taking it 2 meter, 2 meter, 2 meter. Let's say from A to B is 2 meter, B to C is 2 meter, C to D is 2 meter. Let the body is taking 1 second in going from A to B, and 2 seconds in going from B to C, and 3 seconds in going from C to D. So what will be my definition for non-uniform motion? It's just school definition. When a body covers equal displacement in unequal intervals of time. Even I can say in a different way. When a body covers unequal displacement in equal intervals of time, both cases are possible, then we can say body is said to be undergoing with non-uniform motion. However, in college level physics or 11th-12th standard physics, you should be familiar with what is uniform motion and non-uniform motion. The best way to get familiar with uniform and non-uniform motion is, if a body possesses acceleration 0, then we can say that body is moving with uniform motion or uniform velocity or constant velocity. And if acceleration term is there, we can directly say body is undergoing non-uniform motion. Okay. So without discussing much about relation function, limit, continuity, derivative and integration, I will just tell you how to use derivative or how to differentiate a function with respect to x. Let us consider a function y is a function of x given as x only. It means X is independent variable, Y is dependent variable. Value of Y will depend on X. So I want to derive Y or find derivative of Y with respect to X. How I'll do? For that I'll write dy by dx, that will be dx by dx, which is equal to 1 because numerator equal to denominator. So derivative, this can be studied as derivative of y with respect to x. Derivative of y with respect to x, and y is a function of x, whereas x is an independent variable whose value can be arbitrarily chosen, but y value depends on x. Now I'll take another formula. Let y equal to some constant 500. 500 is a constant quantity. Any number is a constant quantity. Now differentiate or derive or derivative of y with respect to x. Sometimes we can say like that. Differentiate y with respect to x. So differentiate y with respect to x means finding derivative of y with respect to x. That will be dy by dx. That will be d by dx. For y I can take 500. So derivative of constant quantity is always 0. Remember this, derivative of constant quantity is 0 because 500 is a constant quantity with respect to x. Example, for uniform motion, you know acceleration is given as, instantaneous acceleration is given as dv by dt. Yes, you know acceleration, instantaneous acceleration, average acceleration is change in velocity with respect to change in time. Now instantaneous acceleration is given as small change in velocity with respect to small change in time. But for uniform motion, you know the velocity does not change, velocity is constant, so I can write a constant. Since velocity is not changing, velocity is a constant, so derivative of constant quantity is 0. So acceleration will be 0 for a uniform motion. Simple. Now third formula. If y equal to x to the power n, now dy by dx equal to d by dx x to the power n equal to n into x to the power n minus 1. Simple formula. Dy by dx equal to d by dx x to the power n into x to the power n minus 1. So d by dx x to the power n into x to the power minus 1, n into x to the power n minus 1. So better to solve a question. Let's say y equal to x square. So find dy by dx. It will be d by dx x square. What will happen here? N is 2. So n into x to the power n minus 1. 2 into x to the power 2 minus 1. 2x. Basically derivative means reducing things. So my primary function was x square. After differentiating it with respect to x, I am getting 2x. 2x is less than x square. Similarly, if I am taking x equal to y equal to x cube, dy by dx, d by dx x cube. So here n is 3. N into x to the power n minus 1, that will be 3x square. So x cube is reducing to 3x square. So whenever we are differentiating something, it will be reduced. And integration is just opposite of this, means accumulation or addition. Okay, y equal to x cube. Similarly, let's say y equal to x to the power minus 3 by 2. Now dy by dx equal to d by dx x to the power minus 3 by 2. It will be n is minus 3 by 2, x to the power minus 3 by 2 minus 1. So minus 3 by 2, n into x to the power n minus 1. So it will be coming around minus 5 by 2. Simple. If you are talking about y equal to x to the power half, find out dy by dx. So d by dx of x to the power half. So n into x to the power n minus 1. So half into x to the power half minus 1 is minus half. So these are the things. So I will discuss two properties of derivative. Suppose one function is given as addition of two other functions. Suppose y equal to u plus v. Don't look at minus now. Let y equal to u plus v. Now dy by dx equal to d by dx of u plus v, which is equal to derivative of first function dy by dx plus dv by dx. This is just like your distributive law. Similarly, if y is u minus v, then dy by dx equal to d by dx of u minus v equal to du by dx minus dv by dx. Let me do an example. Let y equal to x square minus 2x plus 5. Now dy by dx will be d by dx x square minus 2x plus 5. It will be dx square by dx minus d by dx of 2x plus d by dx of 5, just like your property. So this will be n into x to the power n minus 1, n into x to the power n minus 1 minus, look, if it will be d by dx of 2, then the answer will be 0, but it is 2x. So some constant into some variable. So the constant will be taken outside. Now d by dx into x. 2 I have taken outside. Now dx by dx. Plus derivative of constant quantity is always 0 because 5 is a constant quantity. This will be 2x minus dx by dx is 1. So 2x minus 2. So dy by dx is 2x minus 2. Hope you have understood how to find derivative of simple function. So basically I have discussed two important formula, that is d by dx of any constant quantity equal to 0, and second formula d by dx of x to the power n equal to n into x to the power n minus 1, and third formula, if d by dx of 2x is given or 2x square, whatever, constant and variable, then constant will be taken outside, dx by dx, that will be 1, 2, and the property. There are two other properties, multiplication and division. There are more formula like derivative of sin theta, derivative of cos theta, tan theta, sec theta. That I am not discussing here. That will be discussed by your mathematics faculty. But I will discuss those formula which I am going to use. When I will teach laws of motion, I will discuss about multiplicative property of derivative. Thank you.